Hey guys, Mr. Mealy here, going to share my screen and talk to you about some logs, logarithms. Okay, all right, let's go over here. Oop. Okay, get this. Minimize my face. All right. So we learned earlier that this is log form. Okay, and this is exponential form. Okay, and basically you've got the base stays the base. Okay. And then the other two change place. He goes, sorry, goes zoop over there, and then the C goes there. So the A was with the B, and now the C is with the B. Both of them, the B is below it. The B is the base, okay? In the basement, it's the low part, all right? So most of you guys did pretty well on that on the last thing. So we got that. And we also know that log that when I see log x, it actually means that there's a 10 there. And when I see this guy, that's what's known as the natural log, and that is base E. Alrighty, so let me go here and do this, and we'll go to the next slide. So what do we use logs for? Okay, we use logs to solve exponential equations. So when I've got an exponential equation, and we've got our friend x here, we've been solving for x for years and years and years, and now x is up there. Well, I can't subtract, I can't divide, I can't multiply, I can't take the square root. Like, how do I get x by itself? I rewrite this in log form. So it becomes log base 2 of 18 equals x. Well, what do I do with that, Mr. Mealy? Well, I've got x by itself. Is that the answer? Well, it is an answer, but a lot of times you're going to want the decimal equivalent of this. So we're going to go to Desmos here. All right, I'm going to go over here and I'm going to look at functions. Then I'm looking at MISC, miscellaneous. Okay, and then oh my goodness, where is it? Got to get rid of this goofy thing here. Okay, I'm gonna put you up here. All right, and then I see this guy little log a right there, so I'm gonna put him. And it was log base 2 of 18, I believe. So I'm gonna put the 2 there and the 18 right there. And then there's our answer, 4.17. Okay, so that's all we got to do. That's a pretty simple one, right? So I just put it in log form, and then what was it? 4.17. Okay, so 4.17 equals x, and we're done. Okay, so if instead um, we had this guy here, right? We would do the same thing. Instead of log base 2 of 18 equals x, log base 2 of 18 equals x minus 4. We take this, which is the exponent, and would go over there. And then we got what, 4.17 equals x minus 4. So then we would just add 4 and add 4 here, and I would get 8.17 equals x. Okay, so what's important though that I want you guys to realize is that we have to, before we put it in a different form, we have to isolate the exponential expression. So sometimes it's already isolated, like in these first two examples, but sometimes it is not. So here, in these two examples, we don't have the exponential expression isolated. The exponential expression is this 2 to the x, all right? So what am I going to do? First, I am going to add 4, okay, here. And now I've got 2 to the x equals 22. At which point then I can put it in log form, okay? So log base 2 of 22 equals x. Go back over here, changes from an 18 to a 22. It's not going to change it that much. 4.5 would be our answer then. Okay. So, but the key point is that before I put it in log form, I have to get an exponential expression by itself, meaning something with an exponent that's by itself, not this other extra stuff. All right. So then we've got this guy here. We would divide by 4, 2 to the x equals 128 divided by 4 is 2 to the x, Mr. Mealy. Okay. Equals 32 log base x of 32. So remember, we saw a couple. Sometimes we've got x up here and we move the whole x minus 4. I guess there should be parentheses around that, but since they're both small, I think that's pretty self-explanatory. Okay, and so this is going to be a long video. We're going to do it 2 different ways, 2 other places x can be. All right. So where else can x be? X can be the base. All right. So I'm gonna do the medium one first right here. Okay. So I'm gonna do this guy first, and I'm gonna let me actually make let me use the yellow, right? So we've got it in log form. Now I'm going to put it in exponential form. So it ends up becoming x minus 5. This is the base. And now that is going to be raised to the 5th power. And that's going to equal 800. Okay. So now I don't have log. Before I didn't have log, and then I use log. Here, when I start off with log goes away. All right. So when we go to log form or exponential form, log is either showing up or it's going away. All right. So now I need to get rid of this this 5th power here that it's being raised to, right? So what do? I take the 5th root and I take the 5th root of 800. So let me come on over here and let's do a different one, and we will go to functions again and get this guy right here, put a little 5 in there and put a little 800 in there, and boom, we got 3.8. Okay, so we come back here and that means that x minus 5 equals 3.8. This 5th power and 5th root cancel each other out. Then we just add 5 and we get and add 5 and x equals 8.8, and we're done there. Okay. So that's when x is the base. Okay. So it could have been 3x to the 3rd power or x to the 4th power, in which case we would take a 4th root or a 3rd root, and then this one would be all the way done, and this one we would divide by 3 to finish up. The one last place that that x can be, if I'm going too fast, kind of rewind and listen to what I say again and make sure that you've got it. Okay. So this now x is the argument. This is to me the easiest one, which I saved it for last. Okay. So this, when we put it in exponential form, becomes 3 to the 5th power equals x minus 5. So now I don't have to take a root or put it in log or whatever. I can just come on over here, and 3. If you hit shift 6, you get the little exponent there to the 5th power, 243. So we got 243 equals x minus 5. Add 5 to both sides. That was 243. And we get 248 equals x. All right. So we've seen x as the base, x as the argument, and then where x is an exponent. All right. So we've learned how to solve exponential problems using logs and logs problem by putting them in exponential form. Okay, so that is all of that. I appreciate you guys, love you guys, and see you in the next video.